Welcome everybody. I'd like to welcome you here to our event at the Weill Cornell Medical Center Resilient Infrastructure Panel, which is part of Climate Week. And I'd like to thank Cornell University, our partners Autodesk and WSP, and all of our event partners. My name is Rick Geddes. I'm a professor in the Jeb E. Brooks School of Public Policy at Cornell, a joint appointment as a professor of economics. More to the point, I'm founding director of something called the Cornell Program in Infrastructure Policy, or CPIP. When I launched CPIP 13 years ago, this week actually, with an event at the Cornell Club, I envisioned an interdisciplinary academic center that would bring together key leaders and stakeholders that span academia, government, technology, and industry. Because the infrastructure-related challenges and opportunities that we face today as a society demand cross-sector collaboration. 13 years later, I couldn't be more excited to be part of this Climate Week event. As you'll hear in just a few minutes, our esteemed panelists and their respective organizations exemplify this type of collaboration. This collaboration is vital to scaling future-ready infrastructure and accelerating climate resilience. The opportunity to co-host this event is also timely. In the coming months, the Cornell University Program in Infrastructure Policy, or CPIP, please see our website, CPIP Cornell, will be formulating a bold new vision and forging new external partnerships that focus on the intersection of infrastructure delivery, public policy, and technological innovation. So we've lived through ed tech, education tech, we've had fintech. I declare that it's now time for infratech. And we should have a new intellectual movement that I would love to be based at my beloved University, Cornell, that is the academic center of infratech. With this new vision in mind, I'm thrilled to officially kick off the conversation you're about to hear, which exists at the very center of this unique intersection between infrastructure, technology, and policy. I want to extend a very sincere thanks to our host, Weill Cornell Medical Center, as well as our co-sponsors, Autodesk and WSP, and all of our panelists, the distinguished panelists for taking part in this event. I'd also like to thank my relatively new Deputy Director, Scott Scheibel, not Scheibel, as you might think, and Kat Hellman, who has helped enormously to get this event together, and Daniel Soha from WSP. Kat was at WSP, is now at Cornell. So thank you all for participating. With that, I'd like to turn it over to our co-host and moderator panel, Sophia Berger, Earth and Business, Environmental Business Line Executive at WSP. So Sophia, please take it.
Great, thank you so much, Rick. Thank you for hosting us. And there you go, Infratech, the first hashtag of the event today. Good afternoon, everyone. Thank you so much for coming. As was just said, my name is Sophia Berger, and I lead the Earth and Environment business for WSP in the US, and I'm honored to be your moderator for today's session. As we all know, the scale and urgency of today's infrastructure challenges are unlike anything we've faced before. Aging infrastructure, increased severe weather, rapid urbanization, and shifting societal expectations are converging. At the same time that technologies once considered futuristic, like AI, are becoming part of our present reality. As impacts of extreme weather grow, estimates suggest annual losses in infrastructure of $460 billion by 2050, annual losses. And the same study suggests that AI could mitigate 70 billion of those losses. So helpful, but there's still a lot more to do. The moment demands that we rethink how we plan, design, finance, and govern our infrastructure. Resilience is no longer just about hardening a single asset, it's about building systems that are adaptive, interconnected, and equitable, from rural communities and campus testbeds to megaregions and global cities. That's why I'm especially excited about today's conversation. Our panel brings together leaders from government, academia, technology, and industry, each with a distinct lens, but all working towards the same goal, scaling innovation and collaboration to make infrastructure not just resilient, but future ready. So here's how we're going to spend our time together. We'll begin with a quick round of introductions from our panelists, and then we'll explore three themes: the real-world challenges of resilience, the technological and digital enablers, and finally, how systems thinking and cross-sector collaboration can unlock the scale that we need. After our discussion, we will open it up for Q&A, so please start thinking about your questions. And then at the end, we'll end with some bold visions for the future from our panelists. So with that, let's get started. I'll ask each panelist, please, would you briefly introduce yourself, your role, and how your work connects to resilient infrastructure. I'm just going to move this way, and Tom, would you start, please?
Sure. It's a great pleasure to be here. Oops, is this on? Oh, got it. There we go. How's that? Is it good now? Yes. Turn one on. Hi, I'm Tom Wright, President and CEO of Regional Plan Association. Great pleasure to be here this afternoon. RPA is a civic organization based here in New York City that for over 100 years has looked at the major investments and policies that would shape the long-term growth, prosperity, health, and sustainability of the tri-state metropolitan region, New York, New Jersey, and Connecticut. Over that 100 years, we prepared 4 long-range plans. I have to say the last one I did in partnership with my friend Red here, chairing the board committee and overseeing it. And each of those plans has laid out major investments in housing, community development, landscape preservation, infrastructure, transportation, and other things that we thought were going to be necessary for the next generation's growth. For a long time, for about 75, 80 of those years, much of our work was focused on environmentally kind of open space preservation. But really today, of course, resilience, the transition to renewable energy, and protection from larger and more frequent storms, flooding events, and others has become a major part of the work we do. I'll just say I also, in my evenings, spare time, I chair the State Planning Commission in New Jersey, where we're in the process of adopting a new state plan by the end of the year. So I do a little bit of work on the growth management side there too.
Good afternoon. I'm Britt Agarwal. I am the Chief Climate Officer of New York City and the Commissioner of the Department of Environmental Protection. DEP is our water utility in New York City, so both supplies our water and treats it, and now is also in charge of coastal resilience. And so my work intersects with infrastructure resilience basically because in New York City, if there's water where it shouldn't be, or not enough water where there should be, 311 directs those complaints to me.
So now you know why we're all here. Water, electricity, both ubiquitous. So I'm Jeff Weiss, and necessary. I'm Jeff Weiss. I have a couple of hats on, and then I'll give you a minute of background. So in my day job, I'm executive chairman of 2 companies, one called Distributed Sun and the other called True Current. Distributed Sun they both build and operate and deploy things. And we build and deploy in front of the meter for Distributed Sun and behind the meter for True Current. So we're building all kinds of energy plants all around to make systems more resilient. I'm on the board of the Cornell Program in Infrastructure Policy, which is an honor and a pleasure. And I'm also on the board of the National Renewable Energy Labs Foundation. So I have a couple of hats in what I'm saying. I will say that over the arc of what I've done and in my career, I'm a change agent. And I'm always a change agent deploying things and building things. So I've done that in online banking. I've done that in online photography. And for the last 16 years, I'm doing it in energy. And if you think broadly about those industries over time, they've gone through a lot of change. They've required a lot of new technology. They've required a lot of new policy. They've required a lot of new capital. And somehow I just oddly keep showing up and having fun as a change agent. The final thing I'll say, in 100% of the ones that I've worked on, the 3 I described and some others, I've always worked in what used to be called data-driven decision-making, and is now called artificial intelligence, supporting data-driven decision-making. So if you're trying to change something, if you're trying to invest, if you're trying to deploy, you need a lot of data and a lot of simultaneous equations in order to simplify and not waste time. And over a long time, that's something I focused on a lot through a lot of different software, and I'm happy to be here for that reason.
Great.
Hi everyone, my name is Jean Shaw and I'm here with Autodesk. I have a couple of different hats that I wear. I'm both director on the sustainability team where I oversee some of our programs related to internal decarbonization as well as climate transition planning. And I'm also the MD of our portfolio investing through the foundation where we deploy charitable capital as impact investments in climate tech startups addressing mitigation and adaptation. And just for those of you who may be unfamiliar, Autodesk is a global technology company. We make the tools and the platform that supports the AEC and the design and manufacturing industries. And so really the built environment is the core business of the company.
Okay. Hi everyone, my name is Dion Harris. I'm the least impressive one here on the stage. No, I'm joking. No, I'm joking. I'm really impressed with what these are doing. It's an honor. But no, so I work for NVIDIA. So I'm the senior director of our HPC, AI, and cloud infrastructure team. And so I use the word infrastructure purposely, right? Because when you think about a lot of the big revolutions that happened, whether it was the Industrial Revolution, whether it was, things like electricity, right? Like you described, that's part of infrastructure. Also telecommunications, right? We had to build out an infrastructure to really support and make that a part of our daily lives. And so we're in this transition where AI is becoming infrastructure. It's really becoming sort of a essential need for driving business, driving innovation, driving different new approaches to tackle some of the problems we face. And of course, it has its challenges. It requires water. I think the points were raised earlier. It requires lots of electricity, and it also requires lots of thought and effort around how you're building out that infrastructure, whether it's in the form of data centers, in the forms of sort of edge devices, and how you connect and deliver those services is a huge infrastructure challenge. And so understanding how to apply technology and approaches to addressing that challenge as well. So that's one of the core areas I focus on. There's also another area I focus on, which is on a project we have called Earth-2, which is basically harnessing the power of those technologies being, core simulation, first principles-based simulation, AI and emulation techniques, as well as digital twin techniques to help enable the climate tech ecosystem to leverage some of these technologies to actually tackle some of those problems, whether it's getting early detection for, upcoming storms, whether it's planning against extreme, weather events like heat waves and such, to have a better response plan. A lot of those sort of techniques and tools are available, so it's really about connecting with the tech ecosystem to help enable them. So my role tends to straddle between the core infrastructure and then some of the climate tech ecosystem work that we're doing to try to enable that space with AI and other technologies.
That's excellent. Thank you all so much. As you can see, we have a great panel for you and should have some really interesting discussion. As I mentioned, we're going to start at the beginning talking about infrastructure resilience challenges with some of the panelists on this end of the table. And Commissioner, I thought maybe we could start with you. How is New York City approaching infrastructure resilience across different scales, from building level to citywide systems?
Thank you. We're trying to do a lot. And it really does run, it involves thinking about, particularly, let me focus on flooding, which of course has two flavors mainly. One is stormwater flooding, like we've seen particularly acutely over the last several years, most tragically at Hurricane Ida 4 years ago, and coastal inundation, which we saw during Hurricane Sandy 13 years ago. You can address those on a community large scale, right? And we are doing that. We have several $1 billion worth of flood barriers going up on the Lower East Side and Lower Manhattan. We broke ground on a $250 million project to build a flood barrier in Red Hook just last week, South Shore of Staten Island, etc. Those take a decade to plan and 5 years to build. Interestingly, when I was at Red Hook last week, the person who runs the Red Hook local newspaper came up and said, why does it take so long? Because, the Red Hook houses over here, which is a very large NYCHA community that was devastated during Hurricane Sandy, is on the verge of completing a massive retrofit at the building scale, where they are elevating electrical equipment and hardening facilities and things like that. so that if and when they get flooded again, they will bounce back the next morning without any real damage. And that's one of the things that I think is quite hidden. If Hurricane Sandy hit us today, the flooding would basically be the same because a half-completed flood wall doesn't actually keep any water out. Right? So 2 years from now, it would be a very different story when some of those flood walls are complete. But right now, it would look the same. 3 days later, it would be radically different because we have done a lot of work to harden facilities, and so the electrical facilities, the transit facilities, the wastewater treatment facilities that were all decimated by that water, they would hibernate for the 12 or 24 hours during the flood, and 24 hours later, they'd pretty much be back to normal, right? And that is what resilience actually is. What we are now particularly focused on while we do all of this work, and there's parallel work that we've started that's going on stormwater as well, which is in some ways even bigger because it's about the entire sewer system, is educating the smaller scale building owners and homeowners about what they can and need to do. Because we live for 400 years of this city's history, we've lived in a pretty mild climate. The weather has not been out to kill us, right? The Pacific Coast has a history of earthquakes. The Southeast has a long history of hurricanes. The Midwest, everybody knows they've got to protect themselves from tornadoes. New York, really what we've had is blizzards, right? And we've figured out how to deal with blizzards, right? But that's about all there is. And now climate change means the weather can kill us here in New York. And just like we rely on the NYPD to keep the streets safe, but that doesn't mean we don't lock our doors. We also have to make sure that at the building scale, the large building scale like NYCHA, down to the single family home scale, that people are taking responsibility for hardening their own property, as well as building the community scale infrastructure.
Super interesting and a great segue to maybe Tom. If we're talking at the building and system scale in New York City, if we expand now to the regional area, what do you see as the most pressing needs and how can regional planning help?
Yeah, so all of the challenges that Rick talks about, at least at New York City, within the scale of the city, there is a centralized agency, leadership, funding, a plan to try and address these things. We point out at RPA, this metropolitan region has 3 different states, 31 counties, 782 towns and cities, of which New York City is one, and 781 are not. And so kind of, and I feel actually it's appropriate, Dion, that I'm at the far end of the table from you because you're talking about AI. Yeah. And I'm kind of living in a world where next year we will be celebrating the centennial of the Euclid v. Ambler decision, which is to urban planners the kind of when the Supreme Court upheld local zoning as a right of municipalities. And for 100 years we've been living in a world where home rule, local planning, is making so many of the important decisions around land use and investing in policy that then translate into the flooding and the issues that Rick's talking about. And unfortunately, communities, say along the Jersey Shore, the Long Island Sound, if they individually try to make plans to protect themselves, they will end up very effectively flooding their neighbors. And so we need new institutional models in place to try to come to grips with this. And so I would say kind of put the challenge, but what's the regional infrastructure challenge? Well, we don't really even have the models in place to figure out what the regional plan looks like. Now there's a model for us to follow, which was that in the last generation, the concerns that they were having on environmental concern were largely about the drinking water supply and how do we protect our watersheds in eastern Long Island and southern New Jersey, in the Catskills. And we created kind of new types of models, the Highlands Council in New Jersey, the Watershed Agreement for New York City, that looked at how dozens of municipalities were doing their zoning and planning and land use and started to coordinate it to achieve larger regional goals. And I think that something like that could be done, regional commissions to try and create resiliency, but we don't have it yet. And we're going to need new institutional models to do the planning that then starts to do the funding and starts to do the implementation on a regional basis. because the city is, from my perspective, way ahead right here. And I'll just kind of close with after Superstorm Sandy, the U.S. Army Corps of Engineers funded and started to do the harbor and tributary study, which was meant to look at both sides of the Hudson River and the bay and create a master plan for this. And that effort does not give us, right now it's paused, not surprisingly, in the federal environment. But even before that, it was facing real challenges, real headwinds. And those of us in organizations that had spent over decades participating in it had a lot of concerns about the direction it was going. So again, sorry to be the naysayer, but from my perspective, we're going to have to be thinking about the institutional structures that we don't have today and what we need, and being creative the way prior generations were when they invented things like, first Greater New York City in 1898, or the Port Authority of New York and New Jersey, or the Metropolitan Transportation Authority, or other models that have been created that we live with today. We're going to need something like that, really focused at resilience on a metropolitan scale, or all of this, or, I think New York City, I feel more positive about the city than I do the rest of the region.
The governance aspect is very interesting, and maybe we've talked about flooding, we've talked about land use. Let's talk about energy a little bit, Jeff. How do you think distributed energy systems might help and be scaled to help in this resiliency discussion? And what are some of the key policy levers that could unlock investment?
Thanks so much. So as we look at electricity today, we all use electricity all the time, and it's increasing. Broadly, you can think of electricity for all of us as the new oil, right? Electricity, for the first time in generations, is scarce, and it's hard to come by. So if electricity is the new oil, the answer to your question is at the level of a university, a city, a company, a data center, a fleet, anyone who uses power, which is everyone, in addition to all of us at our homes, have the opportunity to control your own environment now in what are called microgrids, kind of for the first time ever. Because if electricity is the new oil, batteries and solar are the new silicon. They're the new silicon because they are the technologies that are coming down in cost faster than anything else. And when you have a broadly applicable technology that comes down in cost and is subject to a lot of technological innovation, the market for it expands a lot. If something costs $1, it has a certain application. If it costs a penny, it has many more applications, and that's all happening. So we have the opportunity to deploy large numbers of batteries. We go to data center companies in my company, and we tell them, hey, we can save you 10% on your electricity. Who wouldn't want to save 10% on their electricity? But in a world of energy scarcity, consumers both need to and have the opportunity to manage, for the first time ever, their sources of power, to deploy storage, to smooth peak loads, and to enhance what they're doing with distributed resources. What people need is what's called firm baseload power. And there's been a broad debate, and then I'm going to pass it, but there's been a broad debate in the electricity sector about the difference between intermittent power, which is what solar and wind are. They happen when the sun shines or the wind blows, and if those two aren't happening, you don't get electricity, as opposed to baseload resources like nuclear and coal and natural gas, which by virtue of their technologies are on all the time, and in fact, they're incredibly difficult and disruptive to turn them off. So they're very different types of generation sources. Because of what's happening in storage, we now have the ability to marry utility scale and really large storage with other resources and make firm baseload generation in a hybrid way, and that's totally new. That's totally new. So we all have this technology that gives us the ability to create more resilience. Every organization has the opportunity to be networked, to be adaptive, and to be collaborative. And from the entity's point of view, from the data center company's point of view, from the industrial, from the school's point of view, in the past, they never either had the opportunity to think about this nor were there technologies and resources for them to deploy against to think about it. In other words, you just said, hey, I need some electricity, and you got it from the utility. Today, the first choice is not necessarily the utility. The first choice is to see what you can do yourself to make yourself more resilient, more reliable, and manage. And then you get the increment from the utility. And that change, which is going to happen over the next 10 years in major ways, is the front of a big change in our society.
We are definitely seeing that with a lot of our clients. What can they do themselves on the energy front? And so this is a great segue, actually, maybe to the technology angle of our panel. And Dion, I'm going to start with you. You kind of pointed to this a little bit in your introduction of yourself. But how do you think AI, digital twins, and real-time data are transforming infrastructure systems? And are there any promising use cases or examples of how you see technology helping on climate resilience?
Yes, and first I'll maybe just follow up on his point around sort of the attraction for some of the different sort of mixes of power, whether you're doing self-gen behind the meter, if you're going to the grid. We were talking before, I had kind of a non-linear path. I spent like 5 years in my career before it was after tech, but brief disruption in tech to go and I worked at the utility in California. I worked at PG&E. And I was actually on the new business side and doing lots of process improvement work. And when you understand that it takes 3 to 5 years to bring any load onto the grid, renewable or other, and the main reason they're trying to make sure that they can ensure the reliability and the safety of the transmission lines, and that anything that jeopardizes that, they have to be extremely careful to model all the scenarios and when they're bringing load and where they can bring load safely. So that in and of itself is a discontinuity, because you have data centers and model builders who are trying to go as fast as humanly possible. And when I tell you, models are evolving every week, there's literally a new model every week that I have to now go and understand and study and understand what's the ramifications for the data center, what's the ramifications for the products and the hardware that run it and support it. So the models just are moving so fast, it's creating this sense of urgency that really forces the users who are building data centers, especially for this purpose, to really look for other alternatives. And renewables and self-generation tends to be a much speedier alternative in terms of getting power up to get the data center functioning. Now, some of the techniques that are used to help that, in fact, there was a report that was just published this week by CSIS, which described how a lot of applications of AI are actually going to help the burden on the grid. So, in other words, being able to do a lot of that load management analysis and modeling and predictive capability can speed up that 3 to 5 year process, which is just getting new load onto the grid. There's also a lot of work and modeling that it takes to actually manage and operate the grid, in terms of being able to know the state of all the transformers, being able to know the state of all the substations, all the components that are used within the grid itself. We describe the grid as this sort of amorphous concept, but it's transformers, it's wires, it's cable. They're very, very technical things. And so being able to monitor and manage and facilitate that in a real-time way, in a granular way. So we've worked with a company called Utilidata that has basically instrumented all of their smart meters. They've instrumented elements of the grid themselves. We've also worked with other companies that actually build digital twins of transformers to be able to formulate and model new innovative designs, as well as to bring a lot of them online quicker. So all of these technologies are definitely a part of what's driving this sort of urgency to get access to this infrastructure and this power to drive more capabilities, but they're also being leveraged in unique ways that help address some of the burden and challenges that's actually introduced.
Super interesting, and I didn't know that about your background with PG&E. That's a great connection point there. So, Jean, let me turn it to you. And from Autodesk's perspective, how do you see your role in supporting climate resilient infrastructure and the potential opportunities and challenges?
Sure. I think that's a really great question, and kind of listening to all of the other panelists, it strikes me that when you talk about grid resilience or flood resilience, this all requires a tremendous amount of investment that just can't possibly be borne by the public sector or utilities themselves, right? And so private sector writ large has a really big role to play to invest in resilience, if not, not just for the benefit of the greater good, but just for the purposes of business continuity, preventing loss and damage, protecting your supply chains, protecting the safety of your workers. So I think, I'm speaking from kind of looking at how corporation has gone through climate transition planning, or lots of them are in the process of doing that. These are kind of key considerations that were never really on the table a few years ago, but now, because of the accelerating impacts of climate change, really are. And so my hope is that companies, irrespective of industry, begin to invest in infrastructure for self-interested business reasons that really translates to broader community-based infrastructure resilience, right? So that's on the side of just really thinking about how do we engage more of the private sector in this challenge. I think specifically speaking to Autodesk, and also companies like Autodesk and WSP, there's kind of an unfortunate reality is that the more that we are facing infrastructure threats because of climate change, the more there's likely a business opportunity, because of all the hardening that you have to do of the built environment, or the rebuilding, the retrofits, all of those things translates to need for engineering expertise, design, building, etc. And so I think that again is also just how do we tap into just the core business of these kinds of companies to really bring to bear both the skills, the capital, the knowledge to start addressing this problem, which is a multi-sector, kind of all hands on deck societal challenge.
That's great. Go ahead.
Let me jump in to reinforce some stuff. So the grid, as Dion was just describing, is actually the largest machine on planet Earth. But the American grid alone is the largest machine on planet Earth. The grid was built mostly in the 20th century. It's old and decrepit. But the owners of the grid, who have companies with balance sheets, don't call it old and decrepit. They say they want to put the new stuff in. Because of what's happening in demand, the grid has to be replaced faster than ever. So in the first 20 years of this century, the 21st century, demand for electrons, electricity, was flat. It was flat because the economy was growing, and yet we as a society did a pretty good job in energy efficiency, and the two kind of balanced. And then a magic trick happened, right, which is you all invented artificial intelligence. And after they did that, we all started loving it, right? Who wants to give it up? Nobody. Who uses it all the time? Everybody. But when you use it, you're using a vast quantity of water and electricity. And people don't realize you're using water and electricity, which are very scarce resources. So we all have to replace the grid. So all the demand for electrons that's happening, there's a lot of different forecasts, and they don't matter for the purpose of this. We either have to increase the grid in America by another 50% or by another 150% or more. It doesn't matter. If you're growing something that's the largest machine anywhere by that amount, and if you know from an investment point of view, by the time that happens, because it takes more than a couple minutes, it takes years or decades, the base doesn't matter anymore because you get to figure out what the new cool stuff is, right? Which is based on new technology. So I'll tell you another secret from a capital market point of view. We're near Wall Street, right? We're told we're New York.
The same thing.
There is unlimited appetite to invest in long duration, low risk cash flows. What's a long duration, low risk cash flow? It's a bond, right? So the trick for the infrastructure investors, for you guys, for all of us, is to create assets which people can invest in that are de-risked, right? Because energy assets are long-term infrastructure, and long-term infrastructure gets financed at a low cost of capital. The trick is to de-risk it. That requires software, that requires AI, that requires policy, that requires technologies, that requires everything in the built environment to come together to make it easier. And we must do that. We must do that in order to, because our economy needs it.
Well, that aligning of interests towards the goals is a great segue to the last section. And, I hope you're all thinking about questions, as we will have time for questions. But the last piece, we did want to talk about that collaboration and that systems thinking. And so, Commissioner and Jean, let me start with you. You kind of talked about this a little bit, Jean, around private sector's role, but how do you see the partnership between government, academia, and industry in helping to bridge between policy and practice? And are there any examples or innovations you've seen where that's been working successfully?
Sure, I can bring in an example from some of the work through the investing we do at the foundation. And I would add philanthropy as sort of another sector too, especially on kind of the early side of innovation where you're looking at really unproven technologies that are moonshots but very much needed. And so who can step up to take the risk of putting in the first dollar to try something new, right? And so I think maybe that as a starting point is usually a good place for academia, the philanthropic sector, and the tech sector to kind of come together, informed by government to really help articulate the priorities. And then I think whether it's capital markets or the private sector kind of coming in and taking things to scale. So that's really kind of how I think of that model. And one current example in our portfolio is actually an initiative that was born out of collaboration with Dahlberg Catalyst, which is kind of a philanthropic initiative. And it is essentially a project that is building digital twins at the city scale to help urban planners really plan for extreme heat and how to essentially monitor resources, identify where the areas within communities inside a city that needs to have the most amount of intervention in terms of cooling, in terms of health infrastructure, et cetera. And so digital twins are usually deployed at the building level at smaller scale. So this is definitely something novel and new. And so, really bringing together those perspectives and those expertise is a place where, something new and innovative can be trialed.
Did you want to add anything?
Well, I guess one of the realities that I've seen in city government over the last 4 years in my current role is that we do most of our partnerships with the private sector through procurement. And the trick is making sure that we are really good definers of what we are trying to procure. I think it is actually really difficult to truly scale partnerships that don't go through a normal process because of all sorts of good government issues. But one of the things we've done that I'm really pleased with, we're actually in the third year now of what we call the Environmental Tech Lab, which is a partnership we do with the Partnership for New York City, which was directly modeled on something they started with the MTA, the Transit Tech Lab, maybe 7 or 8 years ago. And the issue that we're trying to tackle with this is that the traditional way that innovation tries to make its way into government is hard, because usually it is people from, whether it's large companies or small companies, trying to get in to see people in city government to pitch a new product or an idea. And let me tell you, if some lobbyist calls or whatever, and I am asked to take a meeting, most of the time I don't take the meeting, and if I do take the meeting, I'm spending most of that time trying to figure out how to torpedo this person's pitch, because I'm annoyed. And I'm one of the more open-minded people. And so, what we've done with this ETL is we've actually turned it around and actually gone to our operators internally and said, well, what are the problems that you see that you would like a solution to? And then we work with this nonprofit, the partnership, basically to put out that call for solutions to the private sector. And that has proven really, really powerful because it's no longer based on a pitch. It's actually responding to felt needs that these people have said, because this is my job to come to stuff like this and think big thoughts and whatever, but, I've got people who are in charge of repairing water main breaks. And if they're gonna take time out of their day to think about how to implement new technology, it's gotta have a clear payoff in terms of how they can fix the next water main break. It's gotta be really, really relevant. And so that's where having them be in charge of what the area of innovation is and having the private sector meet that I think is one of the ways that we have to make sure we are getting this in. And we have seen any number of solutions on a variety of topics that we have put out come in, and I'm really excited about that, because if you put the people who feel the most burdened in the driver's seat, that's when you will actually gain traction. So some of this is just about how you drive awareness and demand into the government.
That's super interesting, especially when you couple it with, a natural risk aversion in government. And, we work with a lot of public sector clients. We're like, I don't really want to be the leading edge, I want someone else to do that, and then I'll be right behind. So very interesting. Following along on the collaboration piece, this one is for Tom and Jeff. What institutional mechanisms or funding models are enabling cross-sector collaboration and infrastructure planning, and where do you see the most potent opportunities?
Go ahead. Sure. I'll first let me just kind of riffing off of what Jeff said earlier about the need for the scale of the investment in the world's largest machine. Last week, the New Jersey State Planning Commission adopted and approved a new draft final state development and redevelopment plan that's going out for public hearings for hopefully adoption before the end of the year. The New Jersey State Planning Act requires that in addition to this draft plan, the Office of Planning Advocacy also produce something called the Infrastructure Needs Assessment, which was to look at the state agencies and catalog the capital investments across a range of areas that New Jersey was going to need for the next generation. Housing, water supply, wastewater treatment, roads, bridges, mass transit, all of the kind of areas that I'm most used to. And I can't quote off the top of my head the exact numbers, but with water, we have combined sewer systems in Newark and Patterson and places, so we were talking, $20-30 billion. Housing, there's a backlog of 250,000 units or so. And so again, it was in the tens of billions of dollars range. Transportation, which I spent a lot of my time on, they kind of looked at and trying to build a tunnel under the Hudson River and update New Jersey Transit and other things. It was about $66 billion or so. And the modernization of the grid and storage was at $200 billion. It was literally 3 times the second place piece on the list. And it was kind of staggering for many of us to realize that was the assumption of what we would need. But there we were. And so all of a sudden, it's kind of the capital needs for investment in the state are very heavily skewed towards what you're talking about. In terms of institutional models to do that, I'll just put one out there. I always tend to look at something that's working in one field and whether it can be applied to another. And everyone here in New York, even this week with the UN in town, I will say, we are living through the wonderful, extraordinary success of a new public policy for the first time in the United States, which is congestion pricing, which is a user fee, and it is phenomenally successful. And if you haven't been paying attention, shame on you, you should. And because folks in Washington, for some reason, think they can kill it. And it's this basic idea that you charge the people who are using a limited public good, which is the street space. You take some of the external costs that they impose on society, and you turn it back on them to slightly reduce by the $9 fee that everybody's now paying to drive into Manhattan. And if you were already paying a toll in a Port Authority or MTA facility, it's a $6 fee, has had the effect of slightly reducing the demand on the system overall, and by offering off-peak discounts, flattening demand somewhat. So people who were going to come in at 9 in the morning, if they can shift to 6 or 5 o'clock, they do that. Or if they were going to leave at 5 in the evening and they can go a little later, they do that to save money too. those small changes across this entire system are generating enormous revenues and making the entire system work better for everybody. I remember watching one of the politicians who sued to try and stop it, saying, well, if there's less traffic in Manhattan, it'll mean more traffic everywhere else. No, that's exactly wrong. That's not how it works. By reducing traffic in Manhattan, you can actually measure that somebody in northern New Jersey is now getting somewhere faster, even if they're not coming into Manhattan. There's a measurable benefit to them because of the cascading failure of that. And in a way, I guess I think of kind of cars and transportation as being similar to electrons. And also kind of similar to water. And that I think that being very creative about user fees and trying to figure out who benefits from the investments that we're making and how do we create new revenue streams around them that we can use to do the long-term investment. The MTA, of course, is bonding against the $1 billion a year it's making from congestion pricing to do $15 billion worth of capital investments, mostly for state of good repair today. And I think that's a model that we all look at. I'll say I know Rit and some of his colleagues at City Hall have also looked at a kind of business improvement district type model for maintenance and operations on resiliency investments, and that's another one similar in figuring out who benefits most from this system and looking for ways to try and capture some of that benefit. And again, I couldn't come here on Climate Week and not talk about congestion pricing because it is such a huge success. We all have a vested interest.
Go congestion pricing. Let me add why I'm so optimistic, because in fact I am optimistic about this change that we're going through as a society. I mentioned that the grid is the largest machine. I mentioned that the grid was built in the 20th century and it's old and decrepit, so by depth I'm being extreme, but from that point of view, it needs to be upgraded, grown, and replaced. The other thing that's old and decrepit are our regulations around how utilities work. So how the public service commissions work, how that works. But while I'm being pejorative and saying it's old and decrepit, no one's going to snap their fingers and change it. The point of optimism is that because of the way technologies are evolving, the way artificial intelligence is evolving, the way data analytics are evolving, and the way the ability to deploy is evolving at the distributed energy resource and behind the meter level, which is where schools, companies, industry, data centers, it's where they need their power. Because there's the ability to invest and control your environment to a significant extent, there's a tremendous investment opportunity. It's not to do it behind the utilities, but to do it personally on your facility and to the side and integrate it with the utility. And at a systems level and a society level, those hundreds of billions and perhaps trillions of dollars will be invested because each one of them pencils. Each one of them works economically a la carte. And that kind of investment is just going to take off, is taking off, and it's going to take off in a major way. And putting in the Cornell plug for it, like Cornell is like the best place if you're interested in getting a degree in artificial intelligence and AI engineers, and up in Ithaca and next door at the tech campus. And we're just graduating AI literate and industry ready people. So hire them, right? Hire them. They're good. And you are one of them?
I am.
Specimen number one. So that's among my Cornell plugs. But we have there's a fascinating opportunity because of the change that's happening, which is going to happen both in spite of and in front of regulation and policy that exists. So I don't know if you've heard, but these people who are in the artificial intelligence business and the data center business are pretty eager to get going. They want to build, baby, build. They want to grow, and they're just not going to stop. And you know what else they have in addition to being pretty enthusiastic? They have a lot of money, right? They have a lot of money, and they're pretty enthusiastic. So they're not going to put up with obstacles, right? And what they're going to do is put their money where their mouth is and in front of policy and regulation to figure out how to get this stuff done. And a lot of it's going to be at the industrial data center, behind the meter, and do-it-yourself level.
That's so true, especially when the waiting time for turbines and other things like that is so long. We are seeing clients saying, I'm buying it now figure out where I'm putting it because I just know we're gonna need it. Okay, we are gonna have one more question and then we're gonna open it up to Q&A, so prepare yourselves. Dion, last question to you. You talked a bit before about how there's constantly new models coming out and it's shifting all the time, but what are some of the business models or partnerships that you're seeing as most effective in scaling resilient infrastructure?
So when I think about, like we were describing, a lot of talk has been made about the urgency of bringing on new power, both behind the meter and connected to the grid, and how that needs to plug into this incredible growing sort of network of data centers. So I think NVIDIA has taken an approach of there's this concept in NVIDIA called the PIC, which stands for pilot in charge, which means if you have a unique perspective and you're willing to take it on, you can be the pick of a given project, and your sort of objective isn't to necessarily do the work yourself, but to orchestrate the team to get the job done. And so in some ways, I do believe that NVIDIA sees itself as the pick for really organizing this, what we call this AI infrastructure ecosystem. And so, we've been looking at obviously our products and all the things that we want to do to make sure that they're performant, energy efficient, and delivers the best sort of value for customers. But we've also been working with all of the MEP builders and providers within the data center who are building all the mechanical, electrical, and plumbing, and the CDUs and bus bars and all the different elements that it takes to build out the data center. But then we also said, let's reach out to engineering firms and make sure they understand what's required for this building. It's not a traditional data center, so it has lots of different requirements in terms of floor space density for all the heavily loaded, compute dense racks. It has different air and cooling requirements, and it has different requirements in terms of how it needs to connect to power. We've also been working with energy generation folks like GE and others, and we've been working with several startups companies like Emerald AI, which has lots of different technologies. So our idea about bringing this end-to-end process and ecosystem together, whether we call it from chip to grid, and then of course that also ties into policy, because we've talked about so much today that there's a lot of impact that it has on public policy and financing and other stakeholders that need to kind of come into that fold. So we've been extremely open about engaging every part of that ecosystem to try to come up with a common way of saying, how do we do this going forward? What's a repeatable recipe for success, since we know that we have several customers who are lined up to build the next gigawatt data center? Like, how do we give a blueprint or a template by which we can orchestrate this entire ecosystem to demonstrate that collaboration? Because it really requires it. Because like I said, it's a different model than we've had in the past, because the scale, the scope, the financial commitments, all of those elements require sort of a cross-functional, collaborative, stakeholder group.
I love that pilot in charge. I think we're going to use that. That's a good one.
That's right.
Well, good. So I'm going to open it up now. Are there any questions from the audience? Your hand is up first. Yes.
I have a question along the lines of. Yeah, thank you. I have a question along the lines of the investment from AI companies in their own power infrastructure, and how there's a comment about these companies have lots of money and have the ability to invest in this and can push this forward. How do you ensure that people who don't have those resources also still have access to a reliable and resilient grid infrastructure, given, as you're saying, the decrepit state of it in the 20th century investment? So how do you ensure that that doesn't become a kind of situation of the have and the have-nots, where if you're able to invest in your own infrastructure, you have resilient infrastructure, and for all the rest of us, it becomes more susceptible to climate disasters? I guess it's a question for the whole.
Yeah, I'll take a stab at part of the question, and then maybe others can jump in as well. I think there is like I said, there's definitely a discontinuity in terms of timing. Like I talked about before, for the way that the utilities, especially regulated utilities, they basically go what's called a rate case. They say, you know what, here's how much money I've invested in this grid, and this is what I need to invest over the next 3 to 5 years, and this is the return I'll get on that investment, and then therefore the commission says, yes, you can go invest it, and then they go build a plan to invest it, and then it's 7 to 10 years later before anything is built. So for good reason or bad reason, that's how it works. So there's discontinuity in the sense that, like I said, a lot of the AI companies recognize that they're trying to view this as a competitive advantage. They're building the next model, they're building the next set of capabilities. And so the motivating factors for them to come up with power, come up with their own generation on site is really sort of what's driving that. Now, it doesn't mean, I think the other question is usually, I hear it the other way around, which is if they do get on the grid, will that stress the grid and create, other downstream effects for other normal paying citizens who aren't building AI data centers? So I think that's usually how I've heard it described, but I think if people are building behind the grid, I don't think it robs the broader society of getting access to it. In fact, what I've seen is that a lot of those folks who are building behind the grid, it's really a kind of field of dream strategy, because once they build it, the grid comes later, right? Because they want access to that renewable energy. They want access to, because a lot of times they're building, self-sustaining, whether it's green or renewable, or having probably a better base load that can contribute back to the grid. That's an incredible win for the utilities. And so I think it does just have this sort of, this time difference that happens in terms of getting it built and then connecting it later, perhaps.
I'll just jump in from the policy perspective. I think it's an outstanding question. And it's one we're grappling with, because the decision-making processes that we have in place right now are deeply flawed. And if you want to, when you want to build a new data center, that will end up as a land use decision. And it will require some kind of zoning approval and permitting that will have to go through a process that we have in place. Or when we build an offshore wind facility, hopefully someday, eventually that wind will have to come online, and a cable will have to come over some geography somewhere, going through a municipality, which will have to decide whether to permit it or not. And currently, actually, literally there was legislation, I think last year, to try and move that permitting up from the municipal level to a state level, and Governor Hochul vetoed it, giving home rule that veto that they currently have. And if you think that system is working well right now, I tell you to take a look at our housing crisis, because it is a direct result of the fact that we have these parochial interests and local vetoes that have shut down essentially housing production. And what we're talking about is a transformation and investment that will at some point run headlong into these kinds of archaic land use decisions that we have. So there is a problem on the one hand, but I think the question raises a really valid concern on the other, which is that if everything is just kind of permitted without any type of regulatory structure, the haves will get what they want and say, again, the water infrastructure that we have across the region and the nation is deeply uneven, in that certain communities have invested in and maintained theirs and others have not. And will something similar happen with the energy supply or the data supply or other things? And so we're going to have to figure out how to reconcile these kinds of issues. On the one hand, the current processes we use, I worry, will stifle the investment, not allow us to go where we need to go. On the other hand, kind of simply unbridled investment. There's, I think, Gene, you kind of raised the question about the private investment. And that's right, but will it benefit all the communities that need it? I think there's a public policy question there that we're going to have to grapple with.
If you're a hyperscaler and you think you might need a new building called the data center that needs 1 or 2 gigawatts of power, that's an enormous number. In most states, depending on where in the 50 states it is, that could be anywhere from 1% to 5% of the entire state's load. It's a single thing. So the percentage is astronomical. So the going in decision that the investor in that data center has to make is, do they get the power from the grid or do they create new power? right? So if they create, to your question, sir, if they're creating new power and they're literally doing it right there and it doesn't affect the grid or maybe integrates, there ought to be a way, and there are ways for that to actually improve your life if you're in the neighborhood, right? Because through a regulatory process, which doesn't exist entirely right now and is imperfect, they can work together and actually make 2 + 2 = 5. If they come in and they say, hey, we need that amount of power, and we just want to take it from the existing grid, and we want to do a side deal that reduces or uses the electrons that are already being produced, and just allow me to use it because I'm good, right? And take it away from the rest of the grid, that actually would be to your detriment. And there is a policy edge to that. And both are happening, both are being talked about, and it's a much longer conversation.
Great. Another question? Yeah. No, you with the time. Yeah.
I don't need a microphone. I talk a lot. Absolutely. Question probably for this side of the table to begin, but so we talked about modernized energy systems and distributed storage being, delivering double-digit savings in the percentage points. How do you see those benefits showing up in New York? And the reason why I'm asking is, as a user of AI, I don't directly see the electricity costs behind the queries that maybe helped me craft this question, right? But, should the pricing, the changes and savings that we see from companies like Distributed Sun be reflected in consumer pricing? I would argue no, because I'm benefiting from this free service, and so how could those be channeled back in fueling innovation from the players at this table? Maybe starting with Tom, because it's a community question, but.
Oh, God, I think no, honestly, I'd rather the others tackle this.
So, no, it's a community good. It's a community good question. So the grid in New York, you asked about New York in particular. So New York is all states are particular based on the distribution of population, load, industry, and all different things. In the state of New York, it doesn't surprise anyone in this room that 70% of the load in the entire state is in the city we're in. But the landmass of the state is outside of the city that we're in. So there's a barbell in terms of where it is. So when the policy folks in the state of New York looked at what they need, and they said, hey, we have a lot of growth, we have population, we have data centers, we have need for new electrons. You probably looked around Manhattan from a congestion point of view, a different type of congestion. There isn't land to build generation in the city of New York, right? It's too dense and too expensive. So from a macro point of view, the new generation has to be outside, and then the transmission lines have to be built to bring that electricity into the city of New York. So the policy writ large in the state of New York has been to build offshore wind off the eastern coast of Long Island, and a lot of solar in upstate New York. And the policy for solar, if you look at the state of New York, there are 26 million acres, fact for you, in the entire state of New York. And to build the solar that the state policies in the state of New York require and expect, which is 10 gigawatts of solar, requires about 50,000 acres. Okay, so we need 50,000 acres into 26 million. You do the division and decide whether you feel that's disruptive or not. There's a lot of land in the state of New York, big state. So from a policy point of view, that's happening. And then the state has to work on transmission, get it from upstate to downstate, and to have those electrons not be lost and be usable. And there's a lot of investment and a lot of policy, and that will happen. There's an incremental conversation about putting large nuclear facilities in upstate New York, because as you probably know, there's a company called Micron, which uses some of your all's products, that's talking about building an extremely large plant in the greater Syracuse area, which you're very familiar with. And if it does, first of all, that one plant is $100 billion investment, an astronomical number for one plant in Syracuse, in the area of Syracuse, New York. And it needs over a gigawatt of power alone. And the way to do that is with nuclear. So a new nuclear plant has to be built in that vicinity for that to happen. These are huge opportunities. They're huge investments, and they're huge opportunities. And there are tons of technology, tons of policy, and tons of data analytics that have to happen before any of that will get built.
Thank you.
Other questions? Oh, over there.
Hi, I wanted to ask ask a question about water quality, because as climate changes, our storm system and our water quality is not, it's designed for the past and not for the future. And DEP, one of the best things about living in New York has been the investment over 50 years at the cleanest water in 100 years. But it seems to me as precipitation increases and more sewage is flushed into the water, that's going to go backwards. So I guess the first question is there a plan to revisit the long-term control plan? When does that start? And then number two, as AI and better prediction becomes possible, has anybody looked at using that to sort of predict things 24, 36 hours out to be able to change the operation of the sewage treatment plants that we currently have so that we can take care of the CSOs afterwards? Thank you.
Thanks. So just to be clear, first of all, you're talking about ambient water quality, not drinking water quality. And yeah, it is true, of course, as we get wetter over time, we are going to have more, relatively, more rain will lead to more combined sewer overflows. A couple of things actually mitigate against that. The first is counterintuitively, when you get your rain in big bunches as opposed to smaller storms, we're actually having more of your combined sewer overflow is composed of stormwater rather than sewage, right? And one of the mistakes that we've made collectively when we think about the combined sewer overflow issue is we think about gallons of combined sewer overflow. What really matters is how much sewage is going into the harbor, right? So sewage a CSO that's 50-50 is of course 10 times worse than a CSO that is 95-5, right? And that's what you're going to have when you have some of these gigantic, really intense rainstorms, because the amount of stormwater is overwhelming. There's a point of reference that I like to think of. 1 billion gallons a day is what we consume in New York City on a dry day, and a little more than 1 billion goes through our wastewater treatment plants. If we get 1 inch of rain in New York City, that's 5 billion gallons of stormwater. And so it's massive. So a 2-inch rainstorm is literally an order of magnitude. And so I think it's really going to be important to think very, very precisely about what we are trying to solve for and how that will play itself through the system. That is by way of saying we currently don't have any reason to think that the overall efforts around the long-term control plan as it currently stands need to be revised. The changes in precipitation are, for the current long-term control plan. By the way, I should step back. It was a very informed question. The long-term control plan is an agreement between the city and, in fact, the state, which administers the Clean Water Act on behalf of the EPA here in New York. And it's the agreement that governs the investments that DEP and New York City will make to reduce harbor pollution and bring New York Harbor closer and closer to compliance with the Clean Water Act, because the Clean Water Act envisions a world in which all bodies of water are perfectly clean. And just by way of reference, over the last 30 years, we have reduced combined sewer overflows from about 100 billion gallons a year. And again, the blend may change, but of the actual overflows, it was about 100 billion gallons a year at the beginning of this century. And we are now in the 15 to 17 billion gallon range on the average year. So an 85% reduction in a generation. That costs New York City roughly, when you also incorporate upgrades at the wastewater treatment plants to do things like nitrogen recovery, et cetera, probably about $14 to $15 billion were spent on that effort. The next 10 billion gallon reduction, which is what the next 15 years of the long-term control plan, which currently goes out to 2040, is to get us down to a rough run rate of 10 billion gallons a year. That will cost basically the same amount, right? So the first 85 billion gallon reduction will cost about as much as the next $5 to $6 billion reduction, right? Because you do the easy stuff first, and then you do the stuff that gets harder and harder and harder. And so we just kicked off construction, we just got the budget for and got the approvals for a $3 billion tunnel that will reduce combined sewer overflows in the Newtown Creek area. We are working on planning for one that will address Flushing Bay. That will be a $3 to $5 billion effort. And I think one of the things that actually I think this really raises is one of the biggest problems that I see in terms of water quality regulation. The first is that the long-term control plan envisions single-purpose infrastructure. To spend $3 billion and only to solve CSOs is a real problem. And one of the things we have taken to the state is we are in a conversation with them. We are going to propose a change to the long-term control plan to say that this $3 to $5 billion tunnel that will clean up Flushing Bay is actually against the public interest if we are not allowed to redesign it so that it actually addresses the flooding problems. Because where the CSO happens to be is not where people are getting flooded in Queens. And so we need to reroute it. And that raises the bigger issue, which is that, I served in the Bloomberg administration, back then, when the harbor was still pretty dirty, a lot of people would talk to me about the need to clean up New York Harbor. I've been in my current job for 4 years. I have never had a New Yorker who is not affiliated with an environmental advocacy organization come to talk to me about the need to clean up New York Harbor, because New York Harbor is actually really clean. Every elected official and every citizen I have talked to in my official capacity has expressed concerns about flooding. Ironically, there is no legal mandate for us to invest in flooding protection, right? Because there is no Clean Water Act equivalent. And there is a mismatch. You want to think about kind of what the abundance agenda means or whether the climate movement overshot with mandates. There is a massive mismatch where water utilities around the country have mandates that, frankly, the bulk of the public don't see as necessary anymore, but are going to drive their water bills way up. At the same time that the thing that most Americans want from their water utilities is going to get pushed aside because the water utilities have to prioritize complying with regulation. And that is going to be a crisis that both stormwater and coastal resilience is going to drive home, and that climate change is going to cause.
Super interesting in terms of mismatched mandates. We are close to wrapping up. We're going to make sure Tom gets out for his class. He's teaching future urban planners to be cognizant of resiliency, so it's important. So last question to the panelists, lightning round. What is one bold idea or innovation you believe will define the future of resilient infrastructure? Who wants to start?
I'll say, I'll dine and dash here. Actually, Rich just mentioned it. I mean, I think that the abundance agenda is a really interesting new direction. I know there are folks who are concerned about it, but as I've been kind of starting to dig into it, the idea that we have to look at the mismatched mandates and look in the mirror about the way that the regulatory structures that we've created are preventing us from delivering, whether it's resiliency investments or clean energy and renewable energy sources or housing or mass transit or other things. I'm excited about this, and I think it's building movement. I was in Washington a few weeks ago for the National Abundance Conference, and it was a bipartisan group, and people were really talking deeply about these ideas. So I'm pretty excited.
I think very practically, the most important uses of things like AI are, when it comes to resilience, is not about knowing how bad the problem is, but actually about speeding up the solution. So anything related to making engineering and design faster, anything related to construction scheduling, anything that can drive down the cost or the time to delivery of the big projects we need, that's what I'm most excited about.
My big idea is lead into change. Okay, in an era of energy scarcity, and if electricity is the new oil from that point of view, which I said, there's going to be a lot of change. There's $1 trillion needed to fix it, and the $1 trillion is not coming from one place; it's coming from every place. And I'll take you back, just since we're here during the United Nations in New York City, to 125 years ago, when an unlikely person became president of the United States. So Theodore Roosevelt was the youngest president ever, right? He was 43 years old, and it turned out he was a young, fit, athletic person. He loved personally to gallop on horseback through Rock Creek Park, and then he would gallop down to the Potomac River, get off of his horse, and swim across the river. Can you imagine? President of the United States, 43 years old. The fact of his comportment and who he was caused so much change in policy, in interaction, and the relevance to the United Nations is we had, all these countries had ambassadors to the United States when he became president, and they all said back in whatever country they were from, we need a new ambassador. We need someone who can deal with this new president. Does that sound familiar? Change is really important. And when you have a lot of change, you lean into it, you invest into it, and in the electricity, in water, in everything we're talking about, in data centers and power, this is all about, this panel is fascinating because of our backgrounds. It's all about change. Let's lean into it and let's invest and let's get it done.
I think I can be brief, just echoing a lot of the sentiments. I think we are in a moment of transition, and what that means is we're partly living in the old system, and then also just can see what the new system's requirements are and how do we get there. And I think this sort of aligning of incentives of different sectors is what's going to enable that.
Yeah, so to most of what was stated, and I'll actually answer the second part of the gentleman's question about what excites me most is really seeing some of these technologies being used and put to good use to really solve some of the problems that we face. I mean, climate tech is one of those areas where, compute is a necessary resource to help simulate, model, and predict and build, the sophisticated analysis that it takes to make educated decisions around policy, around infrastructure, around design of buildings and so forth and so on. So, seeing the work that's happening in the climate tech ecosystem, we're working with companies like Tomorrow.io, who's using their satellites to give, really highly granularized data to 1 million farmers in Africa. We're seeing, companies like Oratech, who's using their technology to identify wildfires, which is a hot button issue in my home state. So it's really seeing how these technologies can be put to use to solve real problems. So that's the thing that excites me. And again, I think that's the one thing that, being in conferences like this, you hear a lot of great stories and use cases. So again, I think that's the one thing that I'll take away, and hopefully you guys take away as well.
Well, excellent. So thank you so much to all the panelists for the rich discussion. I feel like there were a lot of themes, but a couple that stuck out to me. I think we talked a lot about individual and collective responsibility and resiliency, and we talked about that in lots of different parts, and that both are needed, but we can't let the individual sacrifice the collective. There was good discussion several times about problems driving the solutions, right? So on the adoption front with government, but I think also the mismatched agenda is an example of that too, right? Are we focusing on the right problems to find those solutions? And then also definitely a lot of discussion on who's benefiting and who's paying, and making sure that our interests are aligned as we think about that, especially when the amount we need to invest is such a huge number, right? So thank you so much to all the panelists. I really enjoyed it. I hope you all leave today encouraged to think about the role you can play in making our communities more resilient. Clearly there's a lot to do. On behalf of WSP, Cornell, and Autodesk, thank you again for joining us. And thank you all the panelists for your leadership, your insights, and your commitment to building the future that we all need. Thank you.